Good morning, students. These days we are doing vector spaces. Yesterday we took two examples and we verified whether they were vector space or not. Today we will continue the vector space. Today we consider some standard examples also. So let us see. V is a set of ordered pairs remember set of ordered pairs of real numbers. This is the set of ordered pairs of real numbers. That means this is xy plane in 2D. Sometimes it is denoted by this r square. R cross means R cross R. This is 2D, 2 times. In the similar way, R cube such that belongs to 3D. This is called triplets. Order is fixed, x coordinate, y coordinate and z coordinate. You can say set of points in 3 dimensions. This is set of points in 2D. R cubed here. What is this? In the similar manner, suppose it is this. Such that x1, x2, x3 up to xn belongs to R. N dimensional space. R to the power n means R cross R cross R till this is n times. This is called n tuple. N tuple. Ordered pair. Two things taken at a time. Triplet or triple. Three things taken at a time. Triplet. N things but in order. N things. N tuple. So this is 2 dimensions, this is 3 dimensions, and this is n dimensions. Now we define the property. If I say let V remember V is a set. Which type of elements the set V has? In terms of ordered pair. These are the numbers, remember. X is a real number, Y is also a real number. the operation is defined as what is alpha here? Elements of this. What is beta? Elements of this. Then this is the addition here. Alpha is in terms of pair. Means that alpha is x1 comma y1 and beta is x2 comma y2. Alpha plus beta means x1 comma y1 plus x2 comma y2. What is this? How to add? This is the question. This is given. It must be given. The rule of the operation must be given. How to add? So here, first component is added to first component. I mean to say x1 plus x2 and y1 plus y2. It is like this. This is given to us. So, what is alpha here? The member of this. What is beta here? The member of this. What is the nature of alpha in terms of pair? So I took alpha is this and beta is this. This one must be given in the question. So here two pairs are added, means we add the respective components. x1 is a real number, x2 is a real number, so their sum is also real numbers. This is also real number, so 100% this belongs to B. That means is closed. And this must be given. Okay? Two ordered pairs are added to ordered pairs are added. How to add? The respective components will be added. Respective components will be added. Respective components means if a pair, then first to first and second to second. If we suppose triplet is given x1, y1, z1 and x2, y2, z2, then x1 plus x2, y1 plus y2, z1 plus z2. So we can generalize till n tuple. So here it is. The operation this given by this one. The second one. The operation, this is F and here it is equals to R. Is defined as member. The member of this, suppose I say alpha then it is scalar multiplication. This is a number, this is a vector. So alpha means Suppose it is xy, it is in terms of pair. So it is A, that is Ax, Ay. This is given to us. So, if V is a set having this, operation on V is defined like this: how to add and how to multiply a vector, that is scalar multiplication. So, what is the definition of addition of vectors and what is the definition of scalar multiplication of a vector? Here, F I consider that is the set of the real numbers. Okay. Now, this is closed. Here you look at this. X is a real number. Y is a real number. Remember, the elements of V are called vector. So this is a vector. Means this pair is known as a vector. This is a vector. But this is formed with the help of real numbers. So first you decide which type of the set V is given, which type of the rule of the composition of addition is given, which type of rule of स्केलर मल्टीप्लिकेशन इज गिवन। ये दोनों ऑपरेशंस आपको ध्यान होने चाहिए, ये किस तरह से है, सेट कैसा है, वो आपको ध्यान होना चाहिए। ओके, सो लेट अस सी। Now I write it as the question form. Prove that V is a vector space over R. The set of real numbers provided the addition composition and scalar multiplication be as follows. Nature of the elements pair. So two members of V, this one and this one. Addition composition is defined. It is given in the question how to add this one, and this is the scalar multiplication. This is also given. Okay, so now prove it. Right here. Axioms for addition, properties for addition. So write A1. A1 means the first property of this. We know that with respect to this composition, V is an abelian group. So we have to prove that this is an abelian group. If this is an abelian group, then closure property, associativity, identity, inverse hold. Okay, so let's see. First, let alpha beta belongs to B. That means what is the alpha? X and Y, and beta X and Y. What's the nature of alpha? What's the nature of beta? Pair. If it is x comma y comma z, then we write x1 y1 z1 x2 y2 z2 and so on. Therefore, how to add? This is given to us. This is a real number. This is real. This is sum of two real numbers is a real number. So this is the ordered pair of real numbers like this, and elements of ordered pairs whose members are real numbers be the members of V. So this belongs to V. So for all alpha beta belongs to V implies alpha plus beta belongs to V. Therefore, this is closed. This operation is closed. Okay? Try to understand this example carefully because we will extend it up to n tuple. So question may be given in terms of ordered pair, may be given in terms of triplet, or may be given in terms of n tuple. You have to extend only. Okay? So A2 property associativity. Let alpha beta gamma belongs to B. Suppose alpha x1 y1 beta x2 y2 and gamma x3 y3. These are the numbers. Okay? Let us simplify this. This plus this. We know that the rule is given, so I write it is x2 plus x3 y2 plus. This rule is given to us. Alpha, that is x over alpha. Operation is this. Be careful. Look at the operation. This plus sign and this plus sign. This is the ordinary addition, that is the addition of real numbers. ध्यान से देखना है, addition of real numbers, addition of real numbers. Because when I write alpha as this one, beta as this one, gamma as this one, then I repeat such that x कहाँ से आ रहा है, यहाँ से, y कहाँ से आ रहा है, यहाँ से. X and y are real numbers, components of ordered pair, be real number. ध्यान रखना, v के एलिमेंट्स रियल नंबर नहीं हैं, v के एलिमेंट्स पेयर के फॉर्म में. एलिमेंट्स ऑफ v आर इन टर्म्स ऑफ ऑर्डर्ड पेयर्स. वो पेयर्स किससे बने हैं? जैसे मैट्रिक्स, V is a set of matrices of order 2 by 2 of entries real numbers. इसी क्वेश्चन को मैं दोबारा लिखूंगा लेकिन दूसरे फॉर्म में. यहां जो एंट्रीज है वो इसकी है, तो ये रियल नंबर है और ये रियल नंबर है. इनका एडिशन हो रहा है, ये रियल नंबर, ये भी रियल नंबर, इसलिए रियल नंबर के एडिशन में हम ऑर्डिनरी प्लस साइन यूज करते हैं. यहाँ जो मैंने इसको यूज किया है वो इंटरनल कंपोजिशन है. ये दिमाग में फिक्स होना चाहिए कि हम कौन सा ऑपरेशन कहाँ कर रहे हैं. सो इट इज लाइक दिस, देन इट इज x2 plus x3 y2 plus y3 pair. What is the rule? How to add? First to first, second to second. So this is x1 plus x2 plus x3 y1 plus y2 plus y3. Also, if I do like this, then you remember this is a real number, this is also real number, so this must be in V. ये साथ साथ देखते जाना है कि जो आंसर आ रहा है वो वापस V में है या नहीं, उसको सेटिस्फाई करना चाहिए. ये जो एलिमेंट है आपने इसको अप्लाई किया, आंसर आया, रिजल्ट आया, वापस उसी में जाना चाहिए, V में. इंटरनल कंपोजिशन, यस इट इज दिस. देन व्हाट इज अल्फा? अल्फा मीन्स दिस, बीटा मीन्स दिस. हाउ टू ऐड दिस टू? द रूल इज गिवन. It is x1 plus x2 y1 plus y2. The answer of this, just like this one. Then gamma, that is x1 plus x2 plus x3 y1 plus y2 plus y3. This is also not. You can say the left hand side is equal to the right hand side. Therefore, this is associative property. So associativity holds. Hence, therefore, this operation is associative. This is associative. Okay. Time consuming, but you have to understand. Okay, no shortcut. A3 Third property of addition composition. Let's alpha beta belongs to B such that और ज़्यादा एक्सप्लेन करना हो entries are from set of real number. Okay. Now realize the result as usual. So you know the sum x1 plus x2, y1 plus 2, and you know that this is the member of V. A real number is a real number. Sum of two real numbers. Set of real numbers. Set of real numbers itself is a field. So ordinary plus is commutative. Ordinary multiplication is also commutative. So this I can write x1 plus x2, y1 plus 2. Since R is filled. So this property, commutative property, holds in the numbers, and this is the member. Therefore, remember it is true for all alpha beta. Therefore, is commutative. Okay. Third one. Come to the fourth. Since also therefore this is the pair of real numbers. So 0 is a real number, definitely. So this belongs to B because this is the odd pair. Okay, so now I write. Therefore, there exists for all alpha belongs to B implies, suppose I say if I denote like this, then there is no confusion. This is equal to this. I have put bar, nothing more than it. So there exists 0, 0 belongs to V for all alpha belongs to V implies just verify this. Now instead of alpha, you can write x comma y. Instead of this one, you can write 0 comma 0. So you find the answer. You will find this is alpha. Sorry, it's not e. This is alpha. Therefore, this I denote is the identity element. This is the identity element. Okay. Of the composition this composition is addition. This is additive identity. हिंदी में योज्य तत्सम और भी से जीरो एलिमेंट्स और भी से zero vector. Why vector? Because the element of V are called vectors. That's why it is zero vector. तीन नाम दिए हैं: additive identity, zero elements, or zero vector. So what is the zero vector here? What is the zero element here? What is the additive identity here? It is denoted by this symbol, and this is in terms of ordered pair. So it is 0, 0. If it is triplet, 0, 0, 0. If it is 2D, then the origin point where x-axis and y-axis meet together. In 3D, 0, 0, 0. Again, the origin, x-axis, y-axis, and z-axis meet there. Okay, so let us continue. Page 5. Since x comma y belongs to V, where xy belongs to R. Remember, this is a field. It is a field, that means this has 11 properties. This is abelian group with respect to addition, ordinary addition. This is abelian group with respect to ordinary multiplication. Ordinary means numbers multiplication and distributive property. So if x is the member of this, then its additive inverse exists, and additive inverse of x is minus x. So it is this one. Therefore, remember, if additive inverse does not exist, then this does not belong to this. Since R is a field, so additive inverse exists. Therefore, this is the member. Therefore, this pair is also the member of P. The pair is formed with respect to the elements of this. R के अवयवों से पेयर बनाना है, जो कि V का मेंबर्स है, क्योंकि V में जो एलिमेंट्स है वो पेयर की फॉर्म में है. Okay? Therefore, for all x comma y belongs to R, there exists minus x comma minus y belongs to V. For all x comma y belongs to V means for alpha, remember, there exists such that identity element and both sides. We know that from the abstract algebra. Therefore, every element of V has its inverse. Its additive inverse. So, therefore, is an abelian group. First 5 properties: closed, associativity, identity, inverse, and commutative property. Okay. Next part. Scalar multiplication. This is the opposite. A comma alpha. What is the nature of alpha here? X comma y. So this is scalar multiplication. Again 5 properties as closure for all. So I write here, let alpha beta belongs to V. Better take only one element here. Let alpha belongs to V such that suppose A belongs to scalar. Now by definition, this is real number, this is also real number. Why is it real number? Because x and y are real numbers and A is also real, because we have to prove V is a vector space over set of real numbers. So this belongs to V. Therefore, is closed. Okay, so this is the closure property. It is not necessary that it is always given like this. Not necessary. We will consider one example on that how the rule is given. Here the rule is like this. We have to multiply this element by this and this element by this. This rule is given to us in the question. That's why we people are doing like this. If the rule is changed, the formation will be changed, and we have to verify that this is a member of V or not. Second, we consider distributive law. So, S2. Let alpha beta belongs to V such that alpha x1 y1 and beta x2 y2. Suppose A belongs to R. Now, okay, so A alpha plus beta. It is x1 plus x2, y1 plus y2. By definition of addition composition. Here it is, the definition is given of this scalar multiplication. So this is A times x1 plus x2 and this is A times y1 plus y2. Remember, ordinary multiplication, and here ordinary addition. Here it is external composition. Here it is ordinary multiplication, ordinary addition. This is a real number, this is also real number, real number, real number. So this is an ordered pair of real numbers. Therefore, it is the member of. So, this belongs to now we calculate this. You remember the distributive law, left hand side and right hand side. So I took this is the left hand side, this is the right hand side. Okay. So alpha is this. So to just multiply by the definition, so it will be AX1 A by the answer of this one. You people know that. Then this symbol adjective. A beta, so ordinary multiplication. AX2 and A by 2. ज़्यादा दिमाग नहीं लगाना है, लेकिन दिमाग उसमें लगाना है कि ऑपरेशन किस तरह से हो रहा है. हम बिल्कुल वैसे मल्टीप्लाई कर रहे हैं जैसे मैट्रिक्स को किसी नंबर से मल्टीप्लाई कर रहे हैं, और कोई चेंज नहीं है इसमें. टू पेयर्स, हाउ टू ऐड? नॉट ऑर्डिनरी एडिशन. सो इट इज AX1 प्लस AX2 AY1 plus AY. It's the same case here. AX1 plus AX2 AY1 plus AY. We can do this because they are real numbers, so it is allowed. You can say this one is equal to this one. So distribution over addition holds. So this is the second property. Okay. Now third, that is also distributive property. scalar multiplication. A alpha belongs to B. A alpha plus beta equals to A alpha plus A beta. A plus B of alpha equals to A alpha plus A B alpha. Then AB alpha equals to AB alpha and 1 alpha equals to alpha. These are the 5 properties we have already discussed, but you have to remember the operation. This is vector, this is scalar, so here the sign. It is not ordinary multiplication. Be careful. This is a number, so it is scalar multiplication. Okay, this is scalar multiplication. बार बार मैं नहीं लिखूंगा. यहाँ प्लस का मतलब है दिस इज सम ऑफ वेक्टर्स, मीन्स प्लस के ऊपर गोला आएगा, सर्कल, आपको ध्यान में रखना है. ओके, सो दिस वी हैव डन, this we have done. We will do this third one. So let's A comma B belongs to R. Field scalars, members are scalars. Scalars means numbers. Suppose alpha, that is x1, belongs to B. Now, I consider this. So it is A plus B. Alpha. It is this. ये आपको ध्यान रखना है. Alpha means x comma y. Okay, this is a number, just like A. Simple one. So what was the definition? This number is multiplied by this and this number is multiplied by this. It's a pair. So it is A plus B into x and comma A plus B into y. ऐसे समझ लो कि ये मैट्रिक्स है. This is a matrix and this is a number. So 2 is multiplied by the matrix. So 2 will be multiplied by this as well as this. ये ध्यान में रखना, अपने दिमाग में फिक्स होना चाहिए एग्जाम्पल. Then this is ax plus bx, ordinary multiplication, ay plus by. Finished. And A means alpha means x comma y. Okay. B what is the scalar multiplication? Just multiply, just like matrix. It is ax by definition ay, bx by. How to add? Ax plus bx, ay plus bx. You see, this is number 1, this is number 2. Both are equal. So this distributive property holds. So we have verified this one, we have verified this. Now come to the fourth one. Let A comma B belongs to R and alpha, that is x comma pi, belongs to V. AB alpha means here dot with circle. This is ordinary multiplication. So this is AB alpha, right? This is ABX, AB1. In your mind, you can suppose this is single element K, for example. So this K alpha, comma K, Kx, comma K1. It will be this. And B alpha, B is multiplied by this. So it is Bx, comma By. Now I am writing straightforward. Okay. This is by definition ABX, AB. This is question number 1. This is associativity in multiplication. साहचर्य गुणधर्म किस में है? वो multiplication में है. Okay. And the last, that's 5. Since R is a field, therefore 1 is the multiplicative item. One is the multiplicative identity. That means 1 is a scalar. Now 1, this one, 1 external alpha means x comma y. Use the definition, and this belongs to. Therefore, all the 10 properties are satisfied. Therefore, V is a vector space. Over R. Similarly, as usual, we prove this. The vector space over R. V equals. This says sometimes it is nothing, sometimes it is R square. Remember this set. Okay? That means R square over R is a वेक्टर स्पेस. ध्यान रखना, यहाँ आर स्क्वायर कौन है? ये वी. वी जो है वो आर स्क्वायर का काम कर रहा है, बिकॉज द मेंबर्स ऑफ आर स्क्वायर आर इन टर्म्स ऑफ दिस वन. Similarly, it will be r cubed over r for this. Then this here is x1, y1 and x2, xn, x1, y1, xn belongs to r. That means this is a vector space. Simplify like this. Very important example. These are the particular cases. This is the general case. Now instead of this, if I write like this, try to understand. This is xy such that x comma y belongs to R is a vector space over R. And remember, this is a column matrix of 2, just like this one. To add two ordered pairs is similarly as to add two matrices. Corresponding members will be added. Okay? Set of matrices of order 2 by 2 when entries are real numbers be also a vector space. You just proceed like this. Definitely it is time consuming, but you try to understand the method how to prove a given set, whatever it is, with the given composition, with given rules, be a vector space. Thank you very much. If you have difficulty, write comments in comments box.